Well, g'day YouTube. I had a fella asking questions about email there, Weatherwall, that was cooling for 2 hours and then it would stop cooling. I mean, I can't honestly diagnose a problem on a unit that isn't in front of me, but I guess the first thing is, how do you tell if it's short on gas? Well, you basically need to do calculations using subcooling and superheat, but you don't need to know that stuff to work out roughly if it's, you know, okay, this unit's been running all day, but this is the suction line. I don't know how well you can see that, probably not very, but you can see the body of that compressor is nice and moist. I know it's out of focus, but I've got it focused for the, I can get that. Yeah, so you can see that it's quite cool. It's actually wet. So it's, the best way I've heard it explained is it's like a cold can of beer. And this unit doesn't have a suction line accumulator. That's why the compressor's all sweaty like that. So anyway, zoom back out again. Let's go over to the control gear. I got a lot of, I don't know if this is really better or not, but it's metal and reflective, so you guys are going to have to bear with me. I should have done it hours ago really, but anyway, focused. So what I've basically done here, maybe I should zoom in and show you properly. So I've added a contactor basically. So as you can see there, the top of the contactor is fed straight off the active, off the terminal strip there. So I don't really want to get too near it because it is running, but that contactor is being fed from here. So maybe I should use the black pointer instead. Basically, this is active straight out of, so that comes from the isolator and that goes straight into the top of the contactor there. And it's a three-phase contactor, so I've linked it out so that all three poles in that contactor are doing work. They're spreading the load basically. If we go down to the bottom, no, it's not really ideal lighting. If we go down to the bottom of that contactor, again, I've linked it all out. I'm using that to feed the condenser fan down here, which is out of frame, and this is the feed to the capacitor for the compressor. So if we follow that up, as we can see, he goes straight into that capacitor up there. So yeah, these are original wires here, I haven't changed them. So there's nothing wrong with them, they're not burnt, they look fine. So that's the fix basically, and the later email air Weatherwall actually used a contactor. It was like the best way of explaining it is it was a relay that kind of looked a bit like this, you know. So he used a relay for that. But this unit is too old for that. This is before email started doing it that way. And this is a telemechanique contactor. I know I'm going to get him shot, but it's, you know, it's a beefy contactor. What's it rated for? I think it's rated at 30 amps a leg, so contact set. Yeah, I can't really read it when I'm on that angle, but so what this issue will cause is generally they'll start up and run fine, or they may not. So you might be having the unit running all day and the compressor goes to kick in, and the best thing I can explain is it's just stalled and it trips out the overload, which is, you've never seen it before. I did a live stream, but under that box there, there's a built-in overload, and you'll hear it click. So the best thing I can suggest is get rid of the old capacitor. That's a brand new one. It was 80 bucks from the local electrical supply house, but get a new capacitor, and I suggest rewiring it. You don't have to use a three-phase contactor. You can, you know, three-pole I should say. You can just use a single pole contactor, but yeah, I mean, I've rarely even ever seen a single pole contactor. I'm not even sure if they're available. I mean, I know I've seen them, but not really. So anyway, yeah, that's the fix. You know, you need that compressor to be not switched by the thermostat, because that thermostat switches so many thousands of times over 40 years that you get a high resistance in the contact set, and that causes it to not switch properly. It won't provide full line current at that voltage. So you can measure it with a multimeter. I was going to demonstrate it, but I couldn't measure it because it, you know, really it has to be in that fault scenario to measure, and the problem with that is that the overload in the compressor trips out in less than a second. It's like probably a second in total. So you can bypass the overload, but if you do that, you'll incinerate the compressor in a pretty short amount of time. That overload is there for a reason. So check in the charge, run the unit for 20 minutes or 15 minutes or something, and yeah, the suction line's nice and moist. You know, I can't really, yeah, so it's got all the condensation on the compressor housing builds up over time, but you can see the line is quite, yeah, see, it's quite wet. It's actually quite moist. So yeah, you need cold gas coming back to the compressor basically to cool it down, because that is the compressor's cooling system. That's why it's in this locked box that's insulated with foam, because that's how it cools. So the rejected heat from the compressor comes out of the condenser. That's how it works. Alright, thanks for watching.